if you want to chime in on the chat. Anyways, what we're going to talk about today is procedural generation and this sample chat game called Doors. Doors is included in the Elusive kit right now. If you get your hands on it, you're going to find it in the Doors, wait, what the hell is it called? Door_Doors directory. In there you'll find a variety of, let's call them game assets, which is applicable here, and just a couple of executable scripts, I think. Actually, let's take a look in there. Oh, there's only two, actually. And there's a third part of this, actually, is the door command. So in the kit, you'll find a door command. So this is really an example, actually. It's meant to be an example chat game that you could implement using this bot. So I'll give you an example of a demonstration of its current state. You just type door, or doors. There's a bunch of aliases for it too. And it tells you where you are. And it also says type door help for more, which I'll do right now. It informs us that we are in the Conklin Greenhouse, number 2559. Conklin Greenhouse, so remember that. Door help, the door help command tells us Roverbot 3000 is lost in our Labyrinth HQ. Guided home by remote control. Door north moves in north, and just door N. Oh, never mind. I really botched that. Or you could just use door N, apparently is what I meant to convey. Provide codes with door east and then the code word, and then I tell you to read the manual for more. Which, incidentally, is a dead end. I haven't updated the manual for this command, so you are currently as up to date as anybody gets on the door command. So let's follow its example and type door north, like it said. And it says, the door north into the seriously very, very tiny room is code locked. And it says hint, EANRTENC is what it says. Again, it says EANRTENC. I'll let you think about that for a minute. Sorry about that background noise. It's a heater. It's freezing cold here. Let's see if I can do some. Maybe get it out of the mic range. Arguably even worse. Okay, did you get it? It's entrance. Get it? So here's how you unlock the door northward into the seriously very, very tiny room. You type door north entrance, and hopefully you're seeing this on the screen too. That screen capture is not a typical part of the DronesoundTV displays, but regulars will recognize that. It says, well done, you now have the code to this door. Moving into room 2623. And it says, in the seriously very, very tiny room, number 2623. And it also says, Carlsvat's the pipe fitter is here, needing pizza. So, anyways, before we get into the pipe fitter here, I want to say door south. See, because you might be wondering when we go south what happens. So we're currently in the seriously very, very tiny room, and when we go south, it says that it has unlocked the door with my code and entered the Conklin Greenhouse, room number 2559. Now, if you're quick on your feet and you're thinking in terms of north, south, east, west here, I'm not quick on my feet. I'm trying to find my calculator. 263. I write programs, so I mean that tells you how quick I am. Not quick. I get computers to do that. So, if you are quick on your feet, you will have perhaps subtracted 2623 from, or subtracted 2559 from 2623 and come up with 64. And since we've been moving north and south, may have come to the conclusion that you're in a grid of 64 by 64 rooms, which indeed you are. And there are north, south, east, and west doors in each of the rooms. Now that we've unlocked the door that leads from the Conklin greenhouse into the seriously very, very tiny room, we can just move at will. And you can just type door in instead of door north. We can move at will between these two rooms because we have the code. Because I have the code, actually. Now, if you try this and you tried to move between these two rooms, you would find that you would have to provide the code the first time in order to get this. And we're going to play with how all of that is implemented. That's really the topic of today's show. Hey, so we're back in room 2623. It says this is the seriously very, very tiny room, and it says Carl Watts, the pipe fitter, is here eating pizza. And if you're very, very quick on your feet, you'll notice that that's different from what it said before, because previously when we were in this room it said he was kneading pizza, and now it says he's eating pizza. So he must have gotten his hands on some pizza. And no, I haven't eaten yet today, so maybe that could explain my obsession with pizza, but no, not Carl Watts, the pipe fitter. Okay, so let's say, like for instance, let's go west. So that would be left if you want to imagine you're in this series of rooms here. I wonder if anybody's there. If you're out there, and chime in. It says the door west into the Schiaparelli shed is code locked. It says hint secured. Oh crap, I just translated it in my head. Actually it says hint Derscue, DERSCEU. But anyways, I was like, that's secured. Okay, so west. Door west secured is how we go into that room. So, as I said, all the code for this is in two things. There is the door command, which is in the commands directory. It says, well done, you now have the code for that door. And now we can move at will between those two rooms, between the Schiaparelli shed and the seriously very, very tiny room, number 2623, wherein we again find Carl Watts, the pipe fitter, eating pizza. Okay, so you got the basic model down. How is all this implemented? Well, let's take a look at the door command, and I've implemented this. Actually, you know what, before we do that, I've already talked about how the bot acts as a conduit between chat and all that kind of stuff. So that's not, when I say let's talk about how this works, that's not what I'm talking about. I'm talking about, the game part of this, and hopefully as a template for you implementing your own game of this sort for the bot. Hopefully for that purpose, it is suited. This whole example in this video is suited as an example of like a basic procedural generation foundation for something like this. You might also find this suitable. So that's really what I'm aiming for in this instance. Hold on, I think I just had no, I didn't have a real world. Okay. So, with that in mind, let's talk about procedural generation. And this, if you're doing this in Python or PHP, you will find there are equivalent mechanisms I've found in both of those languages. If you're doing this in JavaScript, you're going to find it a little more difficult. And in Java, it's not a problem, but in JavaScript it is. Because what you need to do this sort of thing is a procedural, is a pseudo-random number generator that can take a seed, that can be seeded, so to speak. So, let me demonstrate. A simple way to generate a random number in a language like Perl might be to say something like int rand. I hope I'm doing this right. I work in so many languages at the same time. Yeah, okay, that's right. I just said print int rand 3, right? On the screen you'll see that. So this will print a random number between 1 and between 0 and 2 actually. 0, 1, and 2. This is 3 in programmer counting. So, and we're not going to dive into what random number generation means in a purely deterministic system like a computer or reality. But you might wonder, like, what is the basis for these numbers? Like, so where do these numbers come from? Clearly, there's not a dice inside a die. There's not a die inside the computer for it to bounce around, for it to come up with a random number. And certainly there is no die with 65,536 sides. So where would you get a random number, as I am now, getting a random number between 0 and 65535? Basically, it uses like a really long, convoluted formula, right? So, as I said, this is a completely deterministic system, and it has no other way to provide you with a value except through computation, okay? And so what it does do is it uses a computation that is hopefully very difficult to predict. So, like, if I told you to take, like, the current time in seconds and add a 1 to it, well, the results would be very easy to predict. But if I have a very long, convoluted formula that has a lot of different permutations, it might be difficult for you to predict what number would come out, even given what input you put in. So, this input that I'm talking about, this thing that you would add to the formula, is called a seed, right? So when we're doing this right here, and I'm just telling Perl to give me a random number, I'm cooking dinner for someone. That's what that ding was. When I'm telling Perl, or any language, you're telling it to give it a random number, it's generally using something like the system clock or something like that as a seed, and there are other sources of seeds, and there are very high quality sources of seeds too, high quality sources of random input. But very often the system clock is used, right? Now, some systems, like Perl, will allow you to actually determine what number, to specify what number is used for this input into this convoluted formula designed to produce a difficult to predict result, right? In Perl, this command is srand. So you type srand and a parentheses and an integer that you wish to use as a seed, and it runs the same random number generation formula as usual, but for input, rather than using the system seconds or some other weird value, it uses this value that you provided, right? So how does that work? Well, as you might imagine, if you provide the same value every time, you get the same result every time, right? So this is the basic mechanism that we're going to exploit for this. This is, let me show you another thing we can do with this. So we're just going to back up one step. And I'm going back to where I'm just printing out one of these numbers, right? So I'm printing out a random number. To make it easy, I'm going to make it a random number between 0 and 255. So int rand 256, right? And what I'm going to do, I'm going to write a real quick for loop here for I equals 0, and we're going to do it until I is less than 100, and we're just going to increment I, so I'm just going to do this 100 times, right? Same thing we've already been doing, but it's going to generate, actually, 1,000. We're going to generate 1,000 of these numbers every, okay, maybe I went a little far. That's kind of hard for you to see. Back off a little. Okay, so maybe 800, maybe 500. Okay, so now I have a for loop here that does the same thing. It generates 500 random numbers, right? In this instance, it starts with 1, 2, 4, 4, 1, 3, 4, 2, 4, 7, blah, 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 blah. And it's 500 of them, right? If I run it again, okay, I get 1, 0, 5, 2, 4, 7, 8, 1, 1, 2, 2, 3. It's, again, another big long string of numbers, right? Now, but if, again, before I begin that loop, I set the random number seed. I'm going to set it to 13 here. It could be any number, but I'm going to set it to 13. And I generate, 500 random integers. I get 1, 2, 5, 2, 3, 2, 1, 7, 8, 2, 3, 6. And if I run it again, what do I get? You know what I'm going to get. I get 1, 2, 5, 2, 3, 2, 1, 7, 8, 2, 3, 6. Recognize the pattern is the same thing. So you get what this is. This is a single integer key to a long sequence of numbers that we can generate like any time, quickly and cheaply with this random function. So I don't have to store these numbers anywhere. I can recall them with this one number and this one function, right? So this is the basic mechanism, right, that I use for doors. So indoors, each room has a number, right? So you saw in the thing where I said door, and it says we're in very, very tiny room number 2623, okay? Room number 2623 is literally the room's seed, right? So I'm going to take a look at, now we're looking at sorry, I should give you line numbers at least. Okay, so now we're looking at the door command, and actually this isn't the best example because the NPC command is actually better. It's a better example of this, but it's not even that big. It's like what, 150 lines maybe, because it uses this procedural generation for everything. All of the properties of the room, including the codes on the doors, and whether or not there's someone in the room, and the name of the room. These are all generated randomly, and I'm using scare quotes right here because they're not generated randomly. They're generated randomly, but they're done so before they are done so. The random number generator is seeded with the room number. So that means the moment the random number generator is seeded with the room number, anything that comes out after that in sequence is going to be exactly what came out the last time this happened, right? So every time you go into a room, the properties are randomly generated, but because the seed is the same for that room every time, the properties are the same every time, and yet appear random. You get it? So I didn't distribute this content. It distributed itself, right, according to whatever the state of the random number generation formula was and the seeds that I've set. Now I do some other stuff, like for instance there is a worldwide seed that gets added to every room, so that if I wanted to change the entire world, I could just change that seed, and that would change all of the rooms and all of their names and all of the people in all of the rooms and everything. So at the top of the door command, there's a seed. It's setting a variable called seed, and it adds, as I said, it starts with the world seed, which is in another file, and it's currently set to 0. I could change it to anything, and it simply calculates the room number, right? In other words, the column, or I'm sorry, the row times 64, since it is, as we calculated, 64 columns wide. The row times 64 plus the column, right? And it's actually offset into world coordinates, but that's not really important. It would work without that anyways. And then, importantly, there's a section here that says, I know there's always a big note in these kinds of programs where it says, everything after this There it is, because right after it starts generating random numbers for any of these properties, that is when the order of things becomes important. Right, so I'm trying to find where it starts generating these. Sorry. Gets the seed and then the room name. Okay, so the room name, it gets that right away, right? So there's a big list of titles. Take a look at that. In the doors directory, there's a file called room_types. Okay, and it's a big list. It's I don't know how many lines is this. 23 lines. Well, not that big. And they say things like deck, gym, suite, library, room, atrium, warehouse, lounge. Interesting. There's another one called room names, and it says things like kind of small, normal sized, just so, Conklin, Blippo, George Brock, undisclosed, terrible paint job, whole other, just a bunch of names that you would combine with room types so that you come up with a room like this seriously very, very tiny room. Let me find another room. We're going to go east, see what that room came out to be. So once it's read these, both the room types and the room name components into a list, and it has seeded itself to the room number, it randomly, quote randomly, I'm using scare quotes, you can't see me off camera, but it randomly picks a room type and munges up a name and decides that the door east leads into the Tintoretto warehouse. And it continues this same mechanism to determine what the code is. It says VUAEEN. I don't actually know all of these. Door East Avenue. I think it's Avenue. Yeah, okay. So, and so that's how all of those properties are generated. This applies also to the NPCs. So in the door directory, there is an NPC script, and I can't remember how it works. I believe you give it a seed. Yeah, okay. So you give the NPC script a room number like 2623. Yeah, that's right. And it tells you who is in there, right? And it's using the same thing. So we can take a look at the doors NPC script, and you'll see actually if you're really watching, in addition to the usual random number generation, procedural generation thing that you see in the other stuff, where I'm setting the key and involving the world key, and then generating all of the properties. I'm generating the NPC type and its name and its home room, that is to say what room it belongs to, what kind of item it has from a list of items, much like the room names and all of that. In addition to all of that, you'll also see that there is some system time stuff in here, and that's because the NPCs have schedules. And the way that I'm doing that, so for right now, just as an example, as I said, this whole thing's meant to be an example for your own implementation of the bot. Just as an example, NPCs currently have 3 states. They are either needing their associated item, or they are eating their associated item, or they are offering their associated item. So, for instance, I believe, if I remember how this works, you can tell it what property you want. Okay, yeah. So it says NPC number 2623 is Carl Votts, the pipe fitter. He lives in room number 2623. His item is pizza, and currently his state, I think it's called, is eating. Okay, and when I ask for his state again, it says that he's eating, and I'm going to keep doing this. Watch. Again, I'm asking for his state. I'm asking for his state, and this is the same output you're seeing when you type doors or door, and you see an NPC there. It's checking the NPC's state. And I know you're wondering, why am I typing this again and again? I thought this was procedural generation. Why would it change? Well, as I said, these have schedules, right? So, and this is what the time stuff was for up in the top of this thing. There we go. Now it says he is needing. It says he's needing, and since his item was pizza, then he's needing pizza. And again, his name was Carl Watts. Carl Watts, the pipe fitter, is needing pizza. See how we determined how Carl Watts, the pipe fitter, was needing pizza. But how did it change over time, right? So, oops, I'm looking at the wrong file. All right, how did it change over time? Well, if you've been paying attention, I think you might have gotten this by now. So I'm using the system, let's say system seconds, right? And maybe let's say we divide them by 60 to cut them down to a much slower game time or something. I'm using the system seconds, say divided by 60, and getting a sine wave of that, right? Such that a value in the NPC, what do I call it here? I think I call it trigger state? Yeah, it's called trigger state. Okay, and here the NPC's trigger state is set to a sine of the clock time plus some properties of its own, of the NPC itself. And then it's, you know, like it's adjusted proportionally. So that basically what happens is his what do I call it? State. His trigger state goes over time between -1 and then 0, and then +1 and then 0, and then -1, you know, a sine wave, right? So, and when it is +1, he has the item, right? And when it is -1, he needs the item. So right now, his state is +1 because he is eating the item, which means he has it. And soon it will go from +1 back to 0 as the sine wave slides back down, and it will repeat. And this repeats for all of the NPCs. Have their own schedules and their own sine waves. Also, if you were watching, you might have noticed that there is an offset to both of those. There's an offset to their time and to their clock. It's called the clock offset. And there's an offset to their trigger state. That way, each of the NPCs will have their own schedules, right? So they don't all, let's say, wake and sleep at the same time. Obviously, you could generate multiple schedules from this mechanism and all that. That's not what we're getting into. But as I said, it's an example of both how you could implement your own game for the bot and of some basic procedural generation fun you could have in the language of your choice. I hope that this serves as a good example. And as I said, I got some real-world work to get back to. I might have some cool hacking stuff to show off pretty soon, if that's ever cleared for release. In the meantime, we return you to your regularly scheduled DroneSoundTV. Thank you for tuning in. As we say around here, if you like it,